A continuación, seguimos con el doctor Woojin Kim. Él es médico radiólogo del Hospital de la Universidad de Pensilvania, con formación en informática en imágenes, de la Universidad de Maryland, Healthcare System, especialista en radiología musculoesquelética y diagnóstico por imágenes, licenciado en neurociencia por la Universidad de Brown y miembro activo del American College of Radiology. Welcome, doctor. It's a pleasure to have you here.
Thank you. I am sharing my screen. Hopefully you can see me and hear me. Could someone confirm, please?
I see your screen, doctor.
Okay, great. All right. Well, muchas gracias por invitarme. I'm going to give a presentation on generative AI and agentic AI in radiology today. So first, the disclosures. Now, I've been asked to give a lot of talks on generative AI in the last couple of years, and so I've been asking this guy to do my introductions for me. Now, what if I were to tell you that I didn't say those words or even write those words? Here's what I did. I took my profile photo and I used a computer program called Midjourney to create some avatars for me. And it did. And I gotta admit, the first one looks nothing like me and it looks more like a K-pop star. So I decided to put that in the I wish category. And sadly for me, I think I do look like the guy at the bottom, but I thought it looked a little too silly. So I decided to go with the one in the middle. Now, after picking the avatar of choice, I asked ChatGPT, hey, I'm about to give a talk on generative AI. Can you come up with some introduction for me, a script? And it did. And I used another program called 11 Labs to clone my own voice, which actually read out the script and created the voice recording. Then I actually took that plus the avatar image and fed it to something called a DID, which created the animation you just saw. Now, I know what you're thinking. You're thinking, hey, Woojin, that's just a lot of work. Why didn't you just take your avatar image and ask AI to animate that instead? And guess what? I did try that. I'm going to pause right there because even for me, it's a little creepy, right? What you will see throughout my presentation today is that I'm going to show you some really, really cool technology. And this technology is amazing, but you have to balance the hype versus reality. And that's what I'm going to do at the end of the talk. Now, don't worry, I'm not going to play this video again, but that was so 2023. This is what I was able to do literally a year later in 2024. Watch. In fact, I can even make it speak different languages. I know I felt like Jason Bourne there for a second. And then earlier this year, I was invited to give a talk in Colombia. And so I decided to give this profile photo animation another chance. And not bad, right? So what's making all this possible? Well, welcome to the world of generative AI. Now, if you've been to any AI talks in the recent years, you've seen diagrams like this one. Well, generative AI, or Gen AI for sure, lives within deep learning, which means that it uses artificial neural networks. Now, the kind of technique that we're used to when it comes to deep learning in radiology is discriminator technique, where let's say I were to train an AI model on a bunch of pictures of dogs and cats. Well, I can show a picture of a cat and ask to classify it, and it will be able to do that. Now, in contrast with generative technique, once I train an AI model on a bunch of pictures of cats and dogs, I can generate a brand new image of a cat from scratch. And that's the difference between these two techniques. Now, I still, do some AI art. In fact, last year at RSNA, I submitted some art pieces, and this is the frozen shoulder piece that got accepted, and another piece, Time is Brain, got accepted. Now, this ability to take a text input and generate images has been around for a while, and Stable Diffusion really became popular when they open sourced it. And radiologists did not wait to take advantage of this technology. In fact, folks from Stanford decided to fine-tune Stable Diffusion and create a more realistic chest x-rays. But I would say, you know what, even these don't look particularly amazing. But literally a month later, the same group came up with Rankin, where you can actually prompt with text like small right-sided pleural effusion and be able to generate realistic-looking chest x-rays simply using text prompts. Now, fast forward, you can actually generate all kinds of medical images using this technique. Now, a couple years ago, I was asked to give a talk on burnout and AI. And so I asked, Midjourney, can you create an oil painting of me being burnt out? And this is what it created, but it was missing something. It was missing a computer monitor. So I drew a region of interest and I said, hey, can you draw me a monitor in front of me? And it did. And this technique is called in-painting. In radiology, we can use techniques like this, as folks from Mayo have done, where I can take a bunch of brain images from MRI, draw regions of interest, and synthetically generate brain tumors. Now, when people ask me, hey, Woojin, what is your favorite AI tool besides ChatGPT? I typically answer by saying Notebook LM. Now, if you haven't used it, I highly recommend you trying it out. It's free to use. What you can do is you can upload PDFs or YouTube videos or whatever documents you have, and it will create a summary for you. But the reason it went viral at the end of last year is because of this particular feature called Audio Overview, where once you click this button, it will create a podcast between two people talking about the very thing you just uploaded. So last year, I was invited to write an editorial in radiology about advancing generative AI research in radiology and wrote this piece. So I decided to, hey, you know what? I wonder what it would say if I were to upload this PDF to Notebook LM. And I promise you, I didn't, prompt this particular thing to say that. So one thing I do ask you is, let's say you're feeling a little down one of these days. You can try uploading your CV to Notebook LM, and I'll guarantee you it will brighten up your day. Now, it has really advanced since its introduction. Now, I was asked to give a talk in Amsterdam recently, and guess what? I can now actually change the language of the output. In this case, I decided to pick Dutch, and guess what? This is what it can do. And I can even ask questions in that language or even in English, and it will respond in the language of choice. And I can make, mind maps. And most recently, I can create video overview. You get the idea. And so now you can use this technique, and you can, definitely try it in Spanish as well. So it's something that I highly recommend. It's been one of my most useful tools. Of course, the thing that actually really made generative AI popular was ChatGPT when it was released in November of 2022. In fact, people are calling it the iPhone moment for AI. But here's the thing. It's not new. It's been around for a long time. In fact, back in the 1960s, Joseph Weizenbaum created a chatbot called Eliza, where it simulated a psychotherapist. Here's a sample exchange. Well, my boyfriend made me come here. Your boyfriend made you come here? He says I'm depressed much of the time. I'm sorry to hear you're depressed. It's true, I'm unhappy. Do you think coming here will help you not to be unhappy? But here's the thing. ELISA works mostly by paraphrasing the user's response. And Joseph Weizenbaum said, I had not realized that extremely short exposures to a relatively simple computer program could induce powerful delusional thinking in quite normal people. In fact, it's been called the ELISA effect. And guess what? We still see this today, as you heard from the previous lecture. Now, what I'm going to do for the rest of the talk is talk about AI in terms of trends that we're seeing and tied to radiology. So the first trend is large language models. Now, if you haven't seen Andrej Karpathy give lectures, his talks, I highly recommend it because he has this amazing talent of breaking down really complex topics into simple form. Here's a case. So the way he describes large language models is the following. Imagine taking a huge chunk of the internet and using a lot of GPUs to create a zip file. Okay, but unlike compressing and creating a real zip file, where if you were to unzip it, you would get the original content back, it's more getting the gestalt of the internet content. Now, chatbots like ChatGPT that are based on large language models work largely by predicting the next word. To be more precise, is predicting the next token, which could be a word or part of a word. And of course, everyone's super excited about generative AI, and radiology is no exception. Pretty much every day I can see some kind of an article out there talking about generative AI and radiology. And certainly there are many potential use cases, but let's be honest, this is a little messy. So I'm going to talk about it in terms of a life cycle of a radiology report. Why? Because as a radiologist, that is my prime work product. And LLMs can assist before, during, and after report generation. Now, before report generation, radiologists typically look for reason for exam, review the prior reports, and review the risk and EMR. And guess what? Large language models can provide summary of all that information, but also be interactive, which means I can ask questions. Now, during report generation, it can convert free text to structured report, check for errors, provide clinical decision support, and even generate impressions automatically for me. Let me give you an example. So today, the way the radiologists work is the following. Because of PACS, speech recognition, and structured reporting, radiologist looks at a particular image and dictates one of the findings in one of the structured fields and go back to the image and do another, finding in another field. And they do this back and forth, kind of like this. And you can see why this is a problem. Now, imagine being able to just tell the AI by looking at the images and only describing the positive findings that you're seeing. And once you're done, let the AI generate the whole report for you. Let me give you a more detailed example. Let's say you have the structured report on the left-hand side, and on the right side, you just literally describe what you're seeing and only the things you're seeing in whatever order that you like. And once you're done, the AI would generate the entire report for you. And this is what LLMs can do. And it can figure out exactly where in the structured field those findings should go, and then be smart enough to keep the pertinent negative language within the report text itself. And afterwards, it will take everything you said and automatically create the impression section in your voice. And let's face it, it's 2025. Anything in green, we really shouldn't have to dictate that manually. What about current study and previous report, right? Unfortunately, a lot of times we can't just copy and paste the previous report because the previous report might have been dictated by someone else. But what if you were to just give it a simple command and say, hey, you know what? Just create an unchanged report for me and let the AI create an unchanged report based in your style. Now I know what you're thinking. You're thinking, hey, Woojin, not every study is exactly the same. What if there's something new, like that red dot you see on the right upper lobe? Well, guess what? You just only talk about that red dot and let the AI take care of the rest of the report, really simplifying the reporting process for you. And today, a lot of reporting solutions only have spell checkers. But there are so many errors that we make, like nonsense words, left and right errors, and so forth, these contradictions. And LLMs can really help fixing those errors. And one of the most popular use cases when it comes to radiology reporting use of LLMs is automated impression generation. But I can tell you, having done this from a commercial perspective for many years before ChatGPT, that people like this particular application of LLMs, not because it saves them time, but because it reduces the cognitive load for the radiologist. I'm sure, a lot of people try to use ChatGPT for this, but the reason why it doesn't really work as well is because of this personalization. It's got to sound like me, the impression. If you ask ChatGPT to create an impression for you, guess what? It's going to create a very generic impression. But I can tell you, if I were to ask 10 radiologists in the room to create an impression on the same chest x-ray, you're going to all create different looking impression. And that's why personalization is important. And afterwards, you can use LLMs to create patient-friendly reports, translate into different languages, and use for data mining. The next trend that we're seeing is large multimodal models. What do I mean by this? Instead of text in, text out, you can take multiple different modalities and get multiple modalities out. So this is an older example, but it really illustrates what multimodal model is. Instead of just texting it, I can put a picture and say, hey, help me lower my bike seat. It will give you the instruction. And then I take a, zoomed up picture, circle it, and say, hey, is this the lever that you're talking about in your instruction? And it will say, no, that's not a lever, it's a bolt, and you need an Allen wrench to loosen it. And I don't even know what that is, so I decide to take a picture of my toolbox and say, hey, do I have the right tool? And it looks at it, it goes, yes, you do. It's on the left-hand side, and it's got a label called DeWalt. And that's what multi-models can do. And the other term that you hear often is this term, foundation model. So what is it? Well, foundation models can take a vast amount of data, and instead of just doing one thing, it can be adapted to do multiple different things. Let me give you a radiology example. Instead of a typical AI solution that you may have seen where you give it a brain CT and it will tell you if there's a brain bleed or not, with foundation models, I can put in multiple different modalities, even clinical notes, lab values, and adapt the foundation model to not only do classification tasks, but also do other things like report generation. So one of the use cases is that particular use case that I'm going to share. And last year at a keynote, I told a whole bunch of people, radiologists, over 1,000 of them in the room, I said, look, I'm going to get controversial. Within a year, you're going to see AI generating reports for chest x-rays and maybe even CT. So was I right? By the way, this completely changed the paradigm of how we do use AI today. Right now, the AI solutions take the images and then gives the finding to the radiologist to generate the report. With this paradigm shift, AI is going to draft the report and let the radiologist sign off. So at the end of last year, a group from Harvard came up with NetVersa, where you can see I can drop in a chest x-ray, give some clinical context, and it will generate the entire report for you. And folks from Stanford came up with Merlin, where you can feed in CT of the abdomen and pelvis, and it will generate the whole report for you. Sure, it's not perfect, but you see where this is going. So was I really right? Well, there's this another paper that came out and say, you know what? Some of these do have still limitations. So there is a little bit of hype versus reality balance there. But this paper from Northwestern came out not too long ago, where they're actually using this in clinical practice, where for x-rays, they're actually feeding into an AI model to generate the report that the radiologist looks and goes, okay, that looks good, make some edits and sign off. The final thing that I'm going to share with you is the agentic AI or AI agents. In fact, a lot of people are calling the year 2025 is the year of AI agents. So what is an AI agent? Well, simply put, imagine having an AI agent. Once I give it a go, it would use LLMs to reason and come up with a plan, then would use various tools to act, and then it will iterate constantly until it generates the output of your choice of desired output. And some people say you need memory. Now, if that's too confusing for you, Simon Willison came up with a nice, succinct definition. An LLM agent runs tools in a loop to achieve a goal. For those of you who are more mathematical, more formulaic, you can also look at this definition, which is using the LLM plus tools plus memory. Now, is this really real? Or is this science fiction? Well, I'll give you some real life examples. So late last year, Gemini released something called Deep Research, where I could actually perform research projects. So in this case, let's say I'm doing research on autonomous vehicle sensor research, it will actually create a research plan. And once I say go, it will actually search dozens, if not hundreds of websites for you. It might take 30 minutes, but afterwards, it will create this report automatically, including tables and citation. The other use case that is real is in coding. So let's say I want to create a game like Candy Crush. I can give it a text prompt, and that's it. And using programs like Cursor, as you'll see, if you pay attention to the left side of the screen, it will actually create a bunch of new files and code this game for you that you can actually play, as you can see here. And I can even make it simpler. I can literally just doodle what I want the application to look like and what it does. And I can take a screenshot of that doodle, feed it to something like Gemini, and can you code this app? And guess what? It will actually create that code for you. So what about medical imaging when it comes to agentic AI? Now, one of the things you probably noticed when it comes to AI in radiology is that everybody's focused on the interpretive use cases. But I wrote a book chapter many years ago where, you know what, AI can benefit all aspects of radiology, which goes beyond interpretation. And no surprise, agentic AI can benefit all aspects of imaging value chain as well. Now, I'm going to end with a couple tips and pointers. Now, I know a lot of folks is focused on clinical accuracy, whether you're in research or in the industry. But as you can see, clinical accuracy doesn't necessarily equate to clinical efficiency. And what I would say is we would take that even further and say that none of those things necessarily equate clinical utility, which I think is the most important for clinical adoption. Let me give you an illustration of what I mean. Let's say I can read 100 x-rays a day or 100 imaging studies. And then my boss buys me an AI solution that can make me read 200 cases a day. Well, that's going to make my boss very happy, but guess what? I'm going to be unhappy, burnt out, probably look for a different job somewhere, unless the very same AI solution can make it feel like I'm reading 50 cases. And that is the challenge for both the researchers in the room and the industry members. The other tip that I have is I know this technology is really impressive, really exciting, but guess what? If your data is dirty, none of that matters. Garbage in, garbage out. So one recommendation I have is before you dive into all these exciting technology, make sure your data is clean. And I have this billboard rule when it comes to using chatbots, and it's the following. Please do not put in anything in a public-facing chatbot, kind of like, for example, PHI, anything you don't want to see on a billboard somewhere. Finally, Microsoft came up with this paper, Frontier Firm. What is it? What they recommended in that paper is that for companies, don't just use AI, create a human agent teams. Now you understand what AI agents are. And then the humans will be the agent bosses. So for the leaders in the room, I challenge you, what can you do today to make sure that you are creating a frontier practice for the future? So my parting lessons, tips for you. First, learn about AI, but don't just learn about AI and read about AI. Learn how to use AI. Try these different tools because that's the only way you understand the potential and limitations. Learn to learn. And just like the previous speaker, learn to think critically. With that, I'd like to conclude my presentation. Thank you for your kind attention. I look forward to your questions later, and please connect with me. Thank you.
Dr. Kim, thank you very much for your interesting talk. Next, we'll be in the question and answer section. So give us a couple minutes to organize. Invitamos a Andrés Naranjo y al Dr. Prada al escenario para acompañarnos en esta sección. También aseguremos que estén en la sección los invitados virtuales, por favor.